In this video, we are going to try to make this game, FloodIt, which is a very clever little game where you have to try to bucket fill the entire board within a certain number of moves. And the way you do that is by selectively choosing what color you're going to bucket fill with. And the fill always starts at the top left. So if I click yellow, then um, then yellow will start filling in from the top. And notice what happens here if I click on red. Now I've bucket filled with red, but now my blob has grown a little bit bigger. And then if I click on the white, or I think that's white, I don't know, light blue, gray, whatever, then I've grabbed all that as well. So if I pick my colors carefully, there's a chance I'll be able to fill up the entire board with a single color in a certain number of moves. Now watch how the pattern actually fills in. What it's doing here, how it's kind of cascading in. That is the BFS algorithm. That is a breadth first search in action. So if you can imagine that the root of the tree is up here at the top left, and the branches are kind of cutting across the tree, or the levels of the tree are going across the tree like that. You can see it's kind of the tree is filling in from top to bottom. And that's kind of one of the enjoyable things about this game, just aesthetically, is watching the colors change. And that's what we're gonna do in this exercise. Now, to make the BFS algorithm work, you need a queue. We could use a list for that. However, .NET provides us a queue class that we'll use instead. So it's actually not a real hard game to make. It's a lot of fun. And it's just kind of clever and elegant. So let's go see if we can make it. I'm going to pop over to Visual Studio here, and I'm going to make a new Windows Form app. Windows Form app. I will call it, maybe, I probably already have a FloodIt program, but hey, no I don't. Lucky me. Okay, so I'm going to make a new form app here, and maybe I will just kind of size it like that. And I'll change the text property on the main window to flood it. There you go. So I'm down here at the bottom right in the properties. I just changed the text. Maybe I'll throw a menu strip on here. So for that, I need to pull up the toolbox, and I will type in menu, and there's my menu strip. Drag that out there. And maybe I'll give myself a file menu, and maybe reset, and quit, or exit. Either way, it's all good. And then under the next menu here, let's have a help menu, and about ... All right, and then let's go fill in our menu items real fast. So reset, we can't do file tool strip menu item click. Did it not give my thing names? Oh no, reset. There we go. Call reset. I'll put in the word to do here up top, because maybe I'll find that in the task list later, right? So if I go up to the view menu here and I select the task list, you'll see that it'll show me, oh, there's something to do on line 27. All right, so what else did we have there? Exit. Also, I just double clicked on that menu thing to create the handler for it, and there's my exit function just to kill the program. Help, and then I'm going to double click on the about option here, message box dot show, and then put in by you by your name, by your name here. There we go. By your name here, right? This is like from Blazing Saddles. State your name, right? No, don't do that. Put your name. Okay. All right, let's get back to our main form, and then we need a picture box on here. So let's bring up our toolbox and throw a picture box control on there. Alrighty. All right, so I had to pull up my calculator. We want it to be 448 by 448. So that will give us a 14 by 14 grid. So actually, rather than trying to drag that out, try to size it using the little guide down here, let's go into the properties for the size and just type in, find the size property for this guy and set it to 448. 448. Uh-oh, that's way too big. Uh-oh, hang on. Okay, you know what? I lied. Let's make these things 20. Every square on our board will be 20, and we'll have 14 of them, and that'll give us 280 by 280, and that'll make our board just a little bit smaller. 280 by 280. There we go. That's nice. There we go. And then maybe we want to put a text box down here at the bottom where we can display how many turns we have left. So let's pull up our toolbox again from the view menu. And I'm just going to throw a text box on here. And then maybe I'll make that a read-only text box. And maybe I'll put a label next to it next here. So there's a read-only property on this text box down here. So right now read-only is set to false on this guy. I can set it to true, and now he's kind of grayed out. And then let me put a label next to it that says how many turns I have left. Turns. Probably want capital T. All right. So there's our interface. Now, what we need to do is we need to be able to paint this picture box here, and we need to be able to listen to mouse clicks on the picture box. So let's go to the lightning bolt here. Well, let's first select the picture box, and then let's go to the lightning bolt. And now we can add events to that. So let's add a mouse click event to that picture box. And I'm just going to double click on the blank area right here. Right, and now we have a mouse event args. The mouse event args is going to contain the coordinate where the mouse was clicked. And we also want a paint event on this picture box right here. So let's go add a paint event and double click on that. All right, now I think we are in business here. Now we can start working on the guts of the program. Let's just define some constants. Constant. So the width of our board is like 14. Width, const, and height is the height of our board is 14, and the pixel size or the cell size. I don't know. Cell size is 20 pixels. All right. Let's define some color codes here. These will be the colors that we have on our board. I don't know, and I'm just making up colors. Red, blue, white. Let's have 6 colors. How about yellow? I'm having trouble with the colors here. How about a light blue? And how about like a purple? There we go. So you can change the colors if you want. The reason I'm balking at this is because a lot of times, I didn't put green in here. All right, let me put a green in here. I'll change purple to green. But if the green and the red are too close and I can't tell them apart, then I'm going to change the green back to a purple or something. But we're not actually going to use these enumerations. And now let's, just for the sake of using the data structures that we already know, let's make a dictionary that maps the these color codes that we've just created to brushes that we can use to actually paint these rectangles on the screen. So to actually draw the rectangles on the screen, we're going to need brush objects. Those have all been predefined for us in the .NET framework. We just need to be able to look them up. So we can use a dictionary object. So we can say, okay, give me the brush for green. Give me the brush for whatever color. Give me the brush for color code 5. Give me the brush for color code 2. We can use a dictionary for that. And I also want to make sure we have system.drawing. Yeah, we've got system.drawing. All right, let's make a dictionary. It's one of my favorite data structures. And it'll map integers to brush objects. And then we let's call it brushes, and let's allocate it equals new dictionary of into brush. And I just hit tab and it auto completes there for me. It's amazing. All right. And then let's actually make our board. We've got to make our board. What's our board going to be? Well, this is interesting. Okay, we're going to have to define what our board's going to be. It's going to have to be some sort of class or struct. A struct is just kind of a mini class. And it's going to have a color code, and it's going to have to know whether it's been bucket filled already. Now, the snag with this idea of doing the bucket fills is that two cells that are next to each other may try to bucket fill each other, and then those will try to bucket fill each other and bucket fill. So the neighbors can get in this cycle of trying to constantly poke each other with a stick like two kids fighting in the back seat of a car. And what we need to do is say, okay, you know what, I've already been bucket filled, so don't bucket fill me again. And that'll stop the program from kind of falling into endless loops. So we'll have to make some sort of little struct that has a color code, an integer color code, so we know what color to draw it with. And it also has a Boolean variable that says whether it's been bucket filled already. So where are we going to put that? Well, let's just go down to the bottom of our file here, and I'm going to add a struct. A struct, again, is just a mini class. Structs are kind of an ancient data type. They go back to the C programming language, and I'll call this thing a square. Structs can contain most of the things classes can contain. There are some restrictions. And they are also reference types. They're not, they're also value types. They're not reference types. And that'll have some implications for us that you'll see here. That'll actually kind of save us a little bit of work. So let's say that this thing has a public int, which is its color code. Could that be a property? Let's see if structs can contain properties. Public. There we go. Structs can contain properties. And then let's also give it a Boolean. Let's call it, I don't know, let's say it's been marked already, or let's call it bucket filled. Let's call it filled. That's a good. Oh, and if it's a property, properties are supposed to start with capital letters. All right. So we have now made a little mini class, a little mini object called a square that going to represent one square on our board, like one of these guys right here. So it's gonna have to know whether it's been bucket filled already to keep the little program from falling into endless loops. One square on the board. All right. So now that we've got this thing defined, we can actually put that. We can start making a two-dimensional array of that. And just for the sake of an experimentation here, what if I put that inside of my? It turns out you can do that. You can have inner classes in C#. So I could have that as a standalone class outside of my main class, my main form class, or I could actually put it in the main form class, in which case it's kind of walled off from other classes. Now I can make a two-dimensional array of those. I can make a grid of them. a 14 by 14 grid. So let's do that. Let me make a two-dimensional array of squares. Square, two-dimensional array. That's the square brackets with the comma. And I'll call it the board equals new square two-dimensional array. Now what are the dimensions? Width and height, and height. There we go. Now, you may be wondering, do I need to make a separate pass over this board to allocate each one of those squares? The answer is no, not in this case, because the squares are structs, and structs are value types. Value types, when you create one, or when you declare one, you get one, just like an integer. When you declare an integer, you get the integer. When you declare a struct, you get the struct. So this kind of saves us a little bit of work, and that's why I went with a struct and not a class. All right, so now let's, and we need to, do we have a variable to keep track of our turns? 25, okay. Maybe we get 25 turns or something like that. All righty, are we good here? All right, this is looking fairly reasonable. Let's make a function to randomize the board now, and a function to draw the board. Maybe I'll go down, well, where will I do this? I don't know. I'll do it down here kind of above my struct. It doesn't matter where in the class you put the function. Let me make a function called reset. And what is this function going to do? Well, let's set turns equal to back to 25. And then we'll randomize the board. We're just going to put random color codes into the board. So we'll need a random number generator. And then we need to go over every row and column of the board, so that those are going to be nested loops. So let's make some nested loops. So I'm going to type FOR and hit tab twice. There's my first for loop. Width. FOR, tab. I'll change that to J. And I hit tab and it just changes them all to J. Height. And then let me say the board at IJ dot color code equals rand.next. How many colors do I have? 6, right? So give me one of those 6 colors. And then it's also got that filled flag, right? So let me set that back to false. Boom. Okay, so there's our reset function. Randomize the board. All right, so drawing the board is going to be almost identical to this. So let's just copy and paste this function, and well, no, you know what? We already have we've got the stub for our function. So let's just grab the loops here, and oh wait, we never built out our brushes. Okay. Before we do our draw function, let's go build our brushes. So up here in our initialize component, build our brush table. We want to build this dictionary of brushes, and that is very easy to do. This is just like we did in Simon building the dictionaries. We can use the array notation, the square brackets, or we can use the add function to add our key value pairs to our dictionary. I guess this time I'll use add just for variety. So I'll say associate, add the key value pair red and brushes.red. So brushes.red is a static object built into the .NET framework. And now I'm just going to clone all this. Oh, sorry, these are all enumerations, or they're constants I created, so I'm just going to keep them being uppercase because I have to. And so there's some cut and paste going on here. And what else? We have white, I believe. White. What am I missing? Red, blue, yellow. Oh, I had a light blue. Okay, sure, why not? And if you're wondering, I mean, there are just a bajillion brushes predefined for us. So, if you don't like the colors, change your colors. There are all sorts of colors to pick from. All right, so now we've built our brushes. Now that we've got these brushes built, now we can actually go do our drawing and see it work. So let's go find our nested for loops down here in our reset function. So these nested for loops, again, we're going to go down every row and every column. Instead of clearing the board, though, or resetting it, randomizing it, we're going to be drawing that square. So let's go find our paint function, which is right here. We'll paint, and we'll paste those loops in here. So what we're going to do now is we're going to draw a rectangle on the board on the canvas that is hiding, or the graphics object that's hiding in this paint event args. And we have is there a fill rect? I believe we have a fill rectangle function. And let's see, there's a whole bunch of overloads for this. 4 overloads. There's a brush, an X, Y, width, and a height. That sounds good, right? Let's do that. So a brush. Well, what's the brush? Well, we'll use the color code in cell IJ to look up the brush in the dictionary. This will save us the hassle of having to write 6 if statements. So let's go into the board at IJ and get out the color code. And then use that as the index into the brushes. So go into the brushes dictionary and get me the brush for what? Well, the brush for the brush for the color code stored in the board at whatever cell I'm looking at. And now I actually have to give it the coordinate to draw the square at, which is going to be I times, was our cell size, J times the cell size, and then the width and the height, which is the cell size and the cell size. Yeah, let me kind of pull this over so we got more room. All right, so that should draw our board. I could probably stand to shrink that just a little bit. Okay, there we go. So that just goes over all the rows, over all the columns. Use the color code in the board to look up the brush for that cell and then draw it at that coordinate, and scaling up our array coordinates to screen coordinates. So let's run this and see if we get a nice, pretty multicolored board instead of a crash. Oop, it's all red. Why is it all red? You tell me. Well, red, I bet, is brush 0, right? Because we never called the reset function. So after we define our brushes, let's call reset. And then in our to-do here where we said call reset, let's call our reset function down here too. There we go. We get a nice pretty board. Whee! Lots of pretty colors. I'm not so sure I like the white, but what are you gonna do? I guess change it to something else. Okay. Alrighty. So Now we can get into kind of the guts of this thing and making it work. And let's well, you know what? I'm gonna stop the recording here. This has gone well enough. In the second video, we'll actually um, do the guts of this thing. So what we're gonna need here is another variable. We're gonna need our Q. I mean, that's really the heart of this whole thing is our Q. And I don't know why I'm highlighting that, but we're gonna need a Q of these squares that we need to keep track of to bucket fill. And now that we've at least got our stuff being drawn, we've got the framework. In the next video, we'll finish it up.